Hello, RJ Kenny here from Link USA to talk to you today about speaker cabling. We're going to start with the physical design and what makes it different than the typical multi-conductor power cable. The first item to look at is the strand size and count in the cable. Our 4 square millimeter or 11 gauge speaker cable is going to be made up of 128 strands, whereas a typical 12 gauge power cable that some people use for speaker cables is going to have half as many. The higher strand count means a few important things. First and foremost, it allows for a more flexible cable while remaining durable enough for portable use. The cable will continue to coil and uncoil easily without turning into a pigtail after years of use. Additionally, the high strand count can help with an issue known as the skinning effect. Higher frequencies tend to want to stay on the outside skin of a strand and not go deep into the core of the copper, increasing resistance. The smaller, higher strand count provides more surface area to prevent any attenuation issues. When it comes to flexibility and durability, a second important feature is the outer jacket of the cable. While typical power cables feature rubber or thermoplastic, which is very rugged, it's not meant for daily movement and particularly in a high conductor count cable. All of Link's cables are made with a specially formulated, highly flexible yet robust PVC jacket that balances these two properties perfectly. The internals of a cable can matter a lot as well. First, all of our speaker cables are color-coded in black and red pairs, marked with what channel number they are for. Those pairs are then kept together as a physical pair, even in the largest cables, with consideration given to how they will align with the matching connector. Also, how these pairs physically lay together can affect the long-term durability of the cable. In larger multi-layer cables, 16 conductors and higher, the layers wrap in opposite directions so there's no way they can physically get in between each other, causing failure. And finally, all of the cables are designed without a center conductor, as this conductor ends up being shorter than the rest and essentially becomes the strain relief for the entire cable. The easiest example of this is an 8-conductor cable. Most are 7 conductors with a center that they wrap around, which when laying on the ground is fine. But in the case of a speaker cable, or a chain motor cable for that matter, the cable being under its own weight for the height of an arena can cause that conductor to fail. Finally, it's important to understand how wire gauge affects the resistance at a given distance, thusly the output of a speaker. Many of the high-end concert speaker manufacturers consider 1 dB of loss to be the highest acceptable amount. Assuming a 4 ohm load at 13 gauge or 2.5 millimeter square, this is around 100 feet, at 12 gauge around 150 feet, and at 4 square millimeter or about 11 gauge at 185 feet or 55 meters. Keep in mind, this needs to include the total length, including any break-ins at the amplifier and breakouts at the speakers. Last, but certainly not least, a reminder that oxygen-free copper is a myth. The standard electrolytic purification method, called ETP, produces copper that is 99.95% pure and actually allows for an over 100% conductivity according to the International Annealed Copper Standard. Being that a cable can't improve the sound, only prevent degradation, once we're over 100%, it really can't make a difference. When you consider the number of additional connections and the dirt and the dust in those connections between the amplifier and the speaker, the idea that the purity of the copper is going to affect the sound is pretty unlikely. For any additional technical information or types of speaker cables and connectors we have available, please feel free to leave us a comment, give us a call, or email us, and we'd be happy to help. Thanks for listening, and we look forward to seeing you next time.